So what's the amplitude? We've kind of been dancing around this a little bit, but what's, by the way, the cosine function, I haven't graphed a cosine yet, but the cosine is a sine wave. It's just shifted left or right, depending on how you think about it. So the properties of the sine of x, the amplitude, and the period will be the same for cosine. So let's get it all stated at once. What's the amplitude of either y equals a times sine bx, so a and b are constants. It's going to be the same as y equals a times cosine of b times x. What's the amplitude? Yeah, you got to be careful. If a is negative, then the amplitude is always positive. You take the absolute value of it. So the amplitude is absolute value of a. And then the period of the same two types of functions. Well, we kind of derived the formula in the last example. The period p is going to equal the regular period of the sine or cosine, 2 pi divided by whatever the constant in front of x is, b. Now, technically, it's absolute value of b, but I can't think of an example where b is going to be negative. So I'm just going to assume that b is positive here. But if it were negative, you'd have to take the absolute value of it, drop the negative. Let's plot one full period of the cosine function. Now, we could plot points here. By the way, if we did plot points, the outputs of the cosine function would be the first coordinates of the outputs of the wrapping function. So if I were plotting points here, the inputs would be perhaps the same as what we used for sine, but then the outputs would be the first coordinates. So the cosine of 0 is actually 1, isn't it? And the cosine of pi over 2 is 0. The cosine of 180 degrees is actually negative 1. The cosine of 3 pi over 2 is 0. And then, of course, the cosine of 2 pi is also 1. But I'm just going to show you the shortcut. The shortcut is the same as it was before, except I have to draw what would be one period of the standard cosine wave, which is shifted. It's a shifted sine wave, and it's going to be between the crests, the tops of the wave. So if we start at 0, that's what it would look like anyway. At an input of 0, it'll actually be at a crest. It'll be at a maximum height, like that. And then I'm going to, just so I have something to aim for, I'll put in the minimum height value, same distance, opposite direction on the y-axis. And then I'll just draw crest to crest part of what would be part of the sine wave, really. This one's harder to draw for me, though.
I thought it would be easier because it's symmetrical.
Yeah, but for me, well, I don't know. It depends on the person. For me, it's harder. Okay. So the period's the same, so I'm going to label this hash mark underneath the second crest first. And that would be the period of just the basic cosine function, which would be 2 pi. And again, I'm going to split that period into quarters, just like I did for the sine, which makes this halfway mark pi. The 1/4 mark is actually an x-intercept here, and that'll be pi halves again. The 3/4 mark, still 3 pi over 2, and that turns out to be an x-intercept for the cosine graph. The amplitude's the same. The amplitude, 1, negative 1. And that's just one period. And that shape repeats itself over and over and over again as you go to the left and go to the right, so that you can see that it would actually form the same shape graph as the sine wave, just shifted horizontally, that is. Okay, so every time you meet a function, what do? You shake its hand. Where's its hand at? I don't know. And then you ask it, what's your domain? Well, I mean, obviously we only graphed a restricted domain from 0 to 2 pi. But in general, the domain, there's nothing you can't plug in. This picture repeats itself over and over again. So think about left to right. Is there any x value you can't plug in? No. So it's the same as sine. The domain is negative infinity to infinity. But what about the range?
From 0 to 1.
Not 0, but negative 1 to 1. Same as sine. Everything's the same so far. Negative 1, it does reach negative 1 and positive 1, so brackets. Period, it's the same, right? Amplitude is 1. It's the same picture, for crying out loud. So of course it's the same. But is it even or odd?
Even.
We know it's even, and let's go back to the picture for a second. What's the main characteristic of an even function? If it's not here, you can't see it because we didn't graph enough of it. But what's the main characteristic of an even function? I'm going to graph one more period to the left. So this would be negative 2 pi over here. Remember, if you fold an even function across the y-axis, it touches, right? The two halves perfectly touch. The two halves are mirror images about the y-axis. In other words, the graph is symmetric about the y-axis if it's an even function. You can't see that if you just graph one period of it, but if you graph there is a way to see it if you graph one period, but it wouldn't be the standard period. So if you graph two periods like I did here, you can see that symmetry about the y-axis.